4.1, where we're going to start solving systems of equations in two variables. And we're going to focus first on graphing the system of equations. And these equations are going to be linear equations. So we're going to be graphing our lines, what we did in chapter 3. All right, what we're looking for is, what do these lines do? Now, these two lines may intersect at one point. They may have parallel lines, or they may be the same line. All right, so if we look at the graphs, here's where two lines intersect. They have different slopes, and anytime you have different slopes, your lines are going to intersect somewhere. So that point right here at 2, 4, down, looks like -1, 4, -1 would be my solution because it's on both lines. You could have two parallel lines that do not cross. Then if there's no points of intersection, we have no solution. And here you can have one line traced over a second line where both equations represent the same line. Then every point on the line is the solution, and you have an infinite number of solutions. But that's not my answer. The equation is my answer. Okay? Now, a consistent system of equation is where your equations have at least one solution. So this intersection, these same lines, those are consistent. Inconsistent is when there's no solution. That would be our middle graph. All right, the other thing I want to point out here again, watch these parallel lines. We know that parallel lines have the same slopes but different y-intercepts. So if we get our equations and we can kind of reduce them down and show that they do represent the same equation or parallel lines, there's really no reason to graph them because we already know what the solutions are going to be. Same thing over here. Slopes will be the same and the y-intercept will be the same. All right, determine which ordered pair is a solution of the system of equations. So these are your x, y points. We're going to take the 2.5, plug it in for both x's. Take the -7.5, plug it in. 2.5 minus 7.5 is -5. Check, that works. 2.5 minus a negative plus 7.5, 10. That works. Both equations are true. They match these answers. That's a solution. Let's bubble it in. Now, again, once in a while this is going to occur. Notice my next point has the same x coordinate, but with a different y coordinate. I can tell you right now, if this one worked, there's no way this one's going to work. So just to show proof, we plug it in. Okay, first equation, 2.5 minus 6.5, -4, doesn't work. 2.5 plus 6.5, 9, doesn't match. I don't know why they would do that. So if you do see that, immediately scratch it off. It's not going to work, especially if you got one that worked already. Let's plug in 3.5 and -6.5. If I plug those in, I get a -3, which is not the same. But the second point, or second equation, does work. So that point is on this equation of the line. It's just not on this one. So it's not a solution. All right? And 1.5 comma -7.5. Check to see if they're going to be in my lines. 1.5 plus -7.5 is -6. That's not a match. 1.5 minus negative, that's plus. 7.5, that's 9. It's not a match. That's not a solution. All right, graphing. Here we have two systems. They have both are in y equals mx plus b. So I'm going to draw this one in blue, this one in red. So we're going to take the first equation, go to the y-intercept of 4. That's this number. Then we're going to take the negative, put it at the top. So down 2, right 3. Plot my point, draw my line. Then we're going to go to the next line, plot +1. That's my y-intercept right there. Up 1, right 3. Up 1, right 3. There's the same point being shared. Draw the line. X marks the spot. 3, 2 is your solution. Next one, again, first line blue, second line red. Let's go again. Plot 4 on the y-axis. That's my y-intercept. Now we're going down 2 and then to the right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Now I always had somebody ask me, how many points do you have to plot? Well, here's the key. When I looked at this second equation, I took a quick peek at the y-intercepts at -2. So since my points are going down towards -2, I'm thinking, okay, we're going to have more points down here where the y-intercept is, and plus if you took a sneak peek at the slope, it's going to go downhill, so it's going to have to intersect somewhere over here. So starting at -2, down 1, right 2, down 1, right 2, okay, X marks the spot, 4, -4 is my intersection. All right, number 3 here, first line in blue, second in red, but that's in standard form. So again, we'll find the X and Y intercepts by using the cover-up technique. Don't forget, you might need to use the slope. Remember, 3 is the A, so -3 over +6 for the B. That's -1/2. So if we need the slope, we can plot more points if we're trying to find out where they intersect. So if we do the standard form, let's do that one first. Let's find the x-intercept, cover up the y. 3x equals 12, x equals 4, x-intercept 4, 0. Cover up the x term, 6y equals 12, divided by 6, y equals 2, that's 0, 2, that's this point. So now, like I said, slope was -1, 2, so you might want to plot some extra points, or if you take your straight edge, draw your line. Here we have a y-intercept at -4. We have a slope of down 2, right 1. Well, I don't want to go down 2, right 1 because I'm looking to intersect the line up here, so don't go down. So let's go in reverse. Up 2, left 1, up 2, left 1, up 2, left 1, and there we finally hit. So, short little line, X marks the spot, -4, 4 is my answer. Now here we have an equation with no X. That means that's going to be horizontal. It's not going to cross the x-axis. So if we do the first one in blue, I go to -1 and draw a horizontal line. X equals 6, there's no y, so I can't cross the y-axis. So I go to x equals 6. Any point above or below, where they intersect is at 6, -1. Wait a minute. The answer is right there. You won't be asked too many of these. They're too easy. All right, number 4. Graph each set of equations and equations on the graph below, then select the option that best describes each solution set. All right, there's going to do a little discovery work here, because we're going to find out you don't have to graph it to answer these questions. All right, so let's go ahead and graph. Blue line, red line. Let's go find the x-intercept of the blue. 4x equals 12, x is equal to 3. Plot that point. Find the y-intercept. 6y equals 12, y equals 2. There's my line. Let's take care of the red one. X-intercept, 6x equals 18, x equals 3, same point. Cover up the x term, 9y equals 18 divided by 9. 18 divided by 9 is 2, same point. Oh, lo and behold, same line. Infinite solutions. Now, like I mentioned earlier, if they wanted you to write the answer, the equation is the answer. So traditionally what we do is you can write it as an ordered pair of points where x is independent. You can choose any x you want, and this is mx plus b. So you'll take one of these equations and solve it for y. Subtract over the 4x, divide everybody by 6, reduce it, that's what you get. Or there's going to be some authors and more that want you to use set builder notation. So left brace, then the ordered pair x comma y, which is my solution, a vertical line which stands for the phrase such that y equals -2/3 x plus 2. This is where you put the equation of the line in slope-intercept form. So they're very closely related. All right, so again, as we said, since it's the same line, the slopes were the same. So -4 over 6, -2/3. 6 over 9, -6 over 9, -2/3. My slopes were the same. Keep that in mind. All right, always finding the slopes are going to tell you what's going on. Over here, blue line, red line. Let's graph this one here. So here, if we started, let's find the y-intercept. 8y equals negative 24, y is equal to 3, plot that point. Cover up the y term, negative 6x equals negative 24, x equals 4, plot that point. There's that line. Okay, let's find this y-intercept. 4y equals negative 8, y equals negative 2. Cover up the y term, negative 3x equals, that's ugly. That's super ugly. All right, so that 3 doesn't go into negative 8. Okay, so what do I need? I need my slope. Negative 3 is 3 over 4. So 1, 2, 3, up 3, 1, 2, 3, right 4. There's my point. There's my line. They're parallel. All right, so again, looking at my slope, negative 6 over 8, 3/4. Negative 3 is positive 3 over 4, 3/4. The lines are parallel. They're not going to intersect, so that's a no solution. Now, here's where I'm saying you don't have to do the graphing. When I see stuff in standard form, I'm always glancing at the slope. So if I look at the slope, I'm going negative 4 over 6 reduces to negative 2/3. Negative 6 over 9, negative 2/3. Okay, my slopes are the same. Well, are they going to be the same line, or are they going to be parallel lines? Both slopes came up to be the same. Here's how you can algebraically tell if they're going to be the same line or parallel lines. Look at your x ratio. 4 over 6 reduces to a positive 2/3. 6 over 9 reduces to a positive 2/3. Your constant ratio, 12 over 18, that reduces by 6 to give you 2/3. If the x ratio, y ratio, constant ratio are all the same, it's the same line. So I, again, take a peek at my slopes. Okay, they're both 3/4. X ratio, negative 6 over negative 3, that's a positive 2. 8 over 4, positive 2. Negative 24 over negative 8, positive 3. Wait a minute. The x and y's were the same, and if the slopes are the same, they should be the same. But my constant ratio is different. That means they're different lines. They're different. They're parallel. Okay? So when you're doing these, you don't always have to graph these. All right? So that's something you want to look at when we look at the other techniques for solving. All right, number 5, using a calculator to solve the system. Okay, so we're going to go to our graphing calculator. You need to solve the equation for y. So I'm going to subtract over the 3x, and then I'm going to divide by 2. There is my work right there. Leave it as one big fraction. We need to solve this for y. Subtract over the x. 1 minus x. Divide everybody by negative 2. Now, you might want to say, well, I don't want to have a negative 2y. I want it to be positive. So be it. You can add over the 2y, then subtract over the 1 to the x, and then divide by 2. Both these fractions are the same. And to prove that, I will graph all 3 of these just to show it. So I go to y equals. If you have the 84 CE calculator where you can hit the alpha, y equals to get to the fraction, that's what I would encourage you to use. If you have the older calculator where you don't have that fraction option, then you're going to have to take what's ever in the numerator, put parentheses around it, divide by 2. Parentheses around the numerator, divide by negative 2. I put parentheses around it just in case. X minus 1 divided by 2. One of the reasons why it's nice to have a positive y term, then you don't have to deal with the negative. So keep that in mind when you have to solve for y and graph. So once I have that, we're going to hit zoom 6. This is what your graph is going to look like, and I paused it. Here would be the first equation in y1, it's blue. Here comes the red and the black line, which is technically the same equation. You can see the red line came across first, then the black one's tracing right over it. Now, you have a command in your calculator that finds that intersection point. So while you have the graph on your screen, hit second trace button. It will activate this window. You want to choose number 5. So either type 5 or scroll down to the 5. It will activate the graph and say, okay, who do you want to be the first curve? It's always defaulted to be y1. Hit enter. Who do you want to be the second curve? Defaults to y2. It goes down the list right here. And you can only find the intersection between two equations. Hit enter. Then it's going to ask you to make a guess. Well, they say move your cursor close. Now you don't have to move it. Only if you have more than two intersections, which we won't. Just hit enter on the guess, and 3, 1 is my solution. That's my ordered pair. Oops, forgot to put my 1 in the box there. All right, so that's how we solve by graphing.